look in this question. In this question, they ask us to draw a displacement time graph, an acceleration time graph. So first thing, they just give us if I want to make a displacement time graph, two displacement time graphs are possible for a projectile which is coming down, depending on what I consider a origin. If I consider this as my origin, so any value, and which is like, it depends on what directions I consider positive, the other directions will be considered as negative. So example, I consider this as my origin and I consider all the downward values as positive. So if I consider all the downward values as positive, all the upward values will be negative. Anything which is pointing up will be negative and anything which is pointing down will be positive. First thing, I want to sketch a displacement time graph. So as it is going down, what happened to the displacement? It is increasing. And I consider all the values which are downward are positive because the displacement is downward. So I'll say the displacement is positive. So upward value will be negative. So means when it is going down, the displacement will increase. What happened to the velocity? The vertical velocity. The vertical velocity will also increase. And in a vertical motion, a vertical plane, there is an acceleration. So if I want a displacement time graph to show an acceleration, so I should show in this manner. I will start from origin and then the displacement is increasing. As the displacement is increasing, so we shows it is increasing and the velocity is also increasing and it is accelerating. So the slope is also increasing. Is it clear? If I consider the top as origin, that is one way of drawing the graph. For a displacement time graph, whenever you show an acceleration, remember one thing, that displacement time graph, when we show object is accelerating, it is always a curve. If we draw a straight line for a displacement time graph, it means it's a constant speed or a constant velocity, which shows that the object is not accelerating. It is moving at a constant speed. And what if you consider the origin at the base? Like you consider this ground is the origin. If you consider this ground as the origin and you consider any directions which are pointing upward are positive, so any direction which are going down are negative. So object, like example, the object was 2 meters above the origin. So it was having a positive displacement. So it means it was having a positive displacement of 2 meters. And then the displacement start to decrease. But what will happen to the velocity? The velocity is increasing. So how to show the displacement time graph? The velocity, the slope is increasing. So first it was having a zero velocity, vertical velocity, and then the velocity, the slope is increasing, which shows the velocity is also increasing. So you can draw a graph like this as well. That is also acceptable. But in this question, because they ask us to draw acceleration time graph and they give us the positive direction, because they ask us to draw acceleration time graph in the first in the question, and they only use a positive axis. So it means if I'm taking acceleration, whenever object is going down, it will accelerate. So means what we consider the origin, it means we consider the origin at this point. We did not consider the origin here. Because if I consider the origin at this point, it means I should use a negative acceleration or the negative axis of the acceleration. So I should have a graph like this for acceleration below the origin, constant line, horizontal line, but below the origin. But as you see that in the question, the acceleration, they only took the positive axis. So what case we'll have a positive axis acceleration? It means when we consider the origin, we did not consider the origin at the ground, we consider the origin at the top. Because when origin is considered as a top and all the downward directions they took as positive, so acceleration was a positive value and the displacement time graph, so it will be like this. Is it clear? Means all the downward direction they consider as positive. Is it clear, this one? If they ask for a negative graph, like example, if acceleration time graph was there and both axes were given, for a displacement time graph, the negative one will be, we have a displacement in time, and like if the displacement was below the origin, it will be a negative displacement, and the velocity is increasing, so the slope should increase, so it will be like this. It shows the slope is increasing. So the graph here is the acceleration, no change, and the displacement, it is zero at the beginning, then it is increasing, the displacement and the velocity is also increasing, so the slope should increase. Page 24, any doubt? Page 24, actually part B you cannot solve. Reason why you cannot solve? Because the formula for the part B was there in part A, which is missing. So you cannot solve part B1. Part B, B1 and 2 you cannot solve because the formula is given in part A, which was not copied. That's why you cannot. So this whole question is actually because of it's related to part A. So as a part A is missing, that's why you cannot solve the remaining one. Page 25, any doubt? This is a velocity time graph. The car travel in the same direction along a horizontal road. The car P passes car Q at time t is equals to 0. The speed limit for the car on the road is 1000 km per hour. State and explain whether the car Q exceed the speed limit. This is like two cars are there which are passing each other. When we start to observe them, when we start to observe these two cars, they pass each other. At time t is equals to 0, the two cars are passing each other. So, and the speed at which the car P was moving at time t is equals to 0, the speed at car P was moving, that was 20 meters per second. And the speed at which the car Q was there, that was 0. The car Q did not start. And acceleration of a car Q is more than the acceleration of a car P, as you can see the steeper gradient for Q as compared to that of P. The speed limit is 100 km per hour. So this is given in meter per second. So what we have to do, we have to just convert into kilometer per hour. And we want to just check if we convert this meter per second into kilometer per hour. So the speed limit for the cars on the road is 100, state and explain. So this is a whole velocity time graph is given. So what is the minimum speed? The minimum speed for the P is 20, and what is the maximum speed? It's about 23. The minimum speed for Q is 0 and the maximum speed is 30. So if we want to check whether they cross the like over speeding, we just check with a maximum value, because if like we just check if 30 is there, it's equivalent to how many kilometer per hour. So 30 meter per second, you want to convert into kilometer per hour. Or you can also do one thing. You can also, because the speed limit is given 100 kilometer per hour. So if I have 100 kilometer per hour, so 100 kilometer per hour, I'll convert into meter per second, and I will check what is equivalent to 100 kilometer per hour. So 100 kilometer and per hour, R is in denominator. First, I want to convert the kilometer into meter. What I will do? Kilometer into meter. So if I want to convert the kilometer into meter, I will multiply by 1000. So means I'll multiply by 1000. So it will be 100 multiplied by 1000, I'll get meter. The time is there in denominator, which is in hour, but I have to convert into second. So if I want to convert hours into second, what I will do? Because first I'll convert hours into minutes, and then I'll convert minutes into second. But because it is in denominator, so the denominator will be 3600. Means 60 into 60, which is 3000. So what's the final answer? 100 into 1000 divided by 3600. 27.7. So 27.7 meter per second is equivalent to 100 kilometer per hour. So the car Q is not like, it means it is exceeding the limit because it is traveling. If it is, the speed limit was 100 kilometer per hour, which is equivalent to 27.7 meter per second. But the car Q is traveling more than 27.7. So it means the car Q is exceeding the limit. Is it clear, this part? Calculate the acceleration of the P, that's the gradient. Determine the distance between the two cars at 12 seconds. How to determine this? So you have to take area under the graph. For Q, it's making a triangle, forming a triangle. So we'll find the area of the triangle. But for P, it will be a trapezium, triangle and a rectangle, or you can take a trapezium. So area of a triangle and the rectangle. And just take a difference, because what we need in the question, we need at 12 seconds the distance between the two cars. So we'll determine the distance traveled by Q, and we'll determine the distance traveled by P. And if I need the distance between the two cars, I will just take a difference of the distance which they total cover. Like example, Q covers, this is just an example, it's not the right answer. Say example, Q covers 180 meters and P covered like 260 meters. Just an example. So how much distance between the two cars? So I'll just take a difference to know what is the distance between the two cars. Then for time t 12 seconds, the velocity of each car remain constant. Determine the time at which Q passes P. So now their velocities are not changing. So we need the distance between the two cars, because to know as like we determine this distance between the two cars, like P is there and a Q is there, and the distance between the two cars will work out. By taking first working out the area under the graph? Why can't just we find a relative speed of approaching? Yeah, we will. You will use a relative speed because as you see, after 12 seconds, they are moving at a constant speed. So, like example, the speed of the car Q is 30 meter per second. And the speed of the car Q is car P, sorry, is 1, 2, 3. I think it's 24, 5, 6, 7, 8, 9. So it is 24. So the speed of the car P is 24 meter per second. So what we do, we work out the distance that which we calculated. Like what is the distance between the two cars? Say the distance between the two cars is 60 meters, example. And the difference in the speed as they're traveling in the same direction. So the relative speed is 6 meter per second for Q. Like, let's take a practical example. Say the car Q was moving at a speed of 30 meter per second and the car P was moving at a speed of 24 meter per second. Okay. And say P is ahead of a Q and Q will overtake the distance between them is example 60 meters. So we want to find how much time the Q will take to overtake P. So what is the relative speed of the Q with reference to the P? What is, if two objects are moving in the same direction, if we need the relative speed, so we just subtract. So what is the relative speed of the Q? It is moving at 30, but P is moving at 24. So what it appeared? It appeared that the Q is moving at a speed of 6 meter per second. So the relative speed of the Q is 6 and the distance between them is 60. So if I need the time, I'll use a formula speed is distance divided by time. So time will be distance divided by speed. So I have the distance between the cars and I know this relative speed of this car. So I will know how much time it will take to like how much, what will the time interval to overtake this car P, which is moving at a speed of 24 and the Q was moving at a speed of 30. So the relative speed was 6 meters per second. Is it clear? Discussion? Yeah, why I took a difference in the speed? Like if I say a person is driving a car at 120 kilometer per hour, okay? And another driver who's ahead of him, but he's moving slower, he's traveling at 100 kilometer per hour. And the distance between the two drivers, the distance between them, example, 40 kilometers. So how much time this driver will take to take over the first one? So he's moving at 100 kilometer per hour constant and he's moving at 120. So what is the relative speed of the driver which is behind? So relative speed of this driver is 20 kilometer per hour. Like for him, like driver A is 120, driver B is 100. So for driver B, it appeared that driver A is only moving at 20 kilometer per hour. And if the distance between the driver A and B is like 40 kilometer, so how much time he will take to cross this driver B? So we have the formula like speed is distance divided by time. So time is distance divided by speed. So 40 kilometers is the distance between them and the relative speed was 20 kilometer per hour. So he will take about 2 hours to cross this driver B if they both move with the same speeds. Is it clear? So whenever two objects are moving in the same direction, the relative speed we take by subtraction. But what if they were moving in the same direction, like opposite directions, and the distance between them is, say, 60 meters, and this was moving at a speed of 30 meter per second, and this was moving at a speed of 24 meter per second. What is the relative speed? What will the relative speed I'll take? So the relative speed I will take as 54 meters per second, because both are moving towards each other. That's why when two cars are moving in opposite direction on the highway, it appears that they're moving much faster as compared to what is their actual speed, because that is a relative speed. So in that case, the relative speed will be 54. Page 27, any doubt? Page number 27. Page 27. Any question or doubt? 27, 28. Part 27, part B. Okay. A paraglider P of a mass 95 kilogram is pulled by a wire attached to a board as shown in figure 2.1. The wire makes an angle of 25 to the horizontal with a water surface. P moves in a straight line parallel to the surface of a water. Variation with time for a velocity is shown, as you can see here. First, it is moving at a constant velocity, and then there's an acceleration. Show that the acceleration at time t is equals to 5 is about 1.4. So means, because this part there is no acceleration, this part is an acceleration. So here t is equals to 5. Because it's a straight line, so whenever it's a straight line, I can take any 2 points. I can take 2 points before, I can 2 points after, or I can take 1 point before or 1 point after. And I'll find the gradient of this region. Like for first point on x-axis will be x1. The second point on x-axis will be x2. The first point on y-axis will be y1. And the second point on y-axis will be y2. And we work out the gradient of this section of a graph. That will give us the acceleration of this glider, paraglider. The next is calculate the total distance move from by P from time t is equals to 0 to 7 seconds. So it's a velocity time graph. Whenever you have a velocity time graph and you need the distance travel, you use area under the graph. So we divide this into parts. We have a triangle and a rectangle. So we'll find the area of the triangle, and we'll find the area of the rectangle. So area of a triangle will be half base into height, and area of a rectangle will be length into width. And that will give us the distance it will cover in first 7 seconds. Then calculate the change in the kinetic energy. If you want to calculate the change for kinetic energy, we don't bother about the directions. We just take the magnitude, because energy is a scalar quantity. So we have the speed here, 10 boxes equals to 2. So each is 0.2. So this is 4.6 meter per second. And time t is equals to 7. So this is, so this one will be 8.8 meter per second. So if we need the kinetic energy, it will be half mv square. The mass of the glider was given 95, and the speed is 4.6 square. And here the kinetic energy will be half. M is a mass 95, and the speed was 8.8 square. And we just take a difference of the two energies. the kinetic energy at the beginning and at 7 seconds. That will give us the change in the kinetic energies. Is it at 8.8 minus 4.6? No, you have to, because we need the change in the kinetic energy. So if we need the change in kinetic energy, it's not the difference, not the difference in velocity. You have to find velocity at 4.6 and you have to find the velocity, like you have to find kinetic energy at 4.6 and kinetic energy at 8.8 and then take a difference. If you do difference in the speed and then square, you will not get the same result. Because as I mentioned yesterday, there's a difference between 8.8 minus 4.6 whole square, and there's a difference between 8.8 minus 8.8 square minus 4.6 individual square and then subtract. The answers are not same. So you have to work out kinetic energy at each point and then take a difference of the kinetic energy, not the difference of the speeds. The tension in a wire at its 280 newtons. Calculate for the horizontal motion, the vertical lift, force F supporting P. So tension in the wire is 280 Newton. This tension will have the two components. Tension will have the two components. One is with an angle, so this will be 280 cosine 25. And another one is the vertical component will be there, which is 280 sine 25. And so that is actually balancing with the weight. Weight is acting downward. The weight of the glider is acting downward. And then like when we take a direction of the tension, it depends on the frame of the reference, which one we consider, because the tension is always to pull. Like if I say direction of the tension for the boat, it will be in this way. Direction of the tension for a boat, it will be in this way. But if I say direction of a tension for the glider, the paraglider, so it is to pull the glider. So that in that case, the direction of a tension will be here. Because tension direction is always to pull an object. They want us to calculate the force of the lift. That is, they want us to calculate. But the glider is because he did not change the position. So it means the lift is the total upward force that will be balanced with the total downward force. So this tension will have the two component. One is this will be T cosine 25, which is acting horizontally. No, he don't have a resultant horizontal, because horizontally, like he remain at the same level. So there's no resultant force in the vertical motion. There is a force on the horizontal motion which causes an acceleration, but he did not change the vertical level. So vertically, there is no resultant force. So if vertically there is no resultant force, so means the total upward force must be equals to total downward force. So the tension will have the component. This will be T sine 25. So T sine 25 is acting downward and the weight is also acting downward. So we want the force of the lift. So in this case, because there is no resultant force, so the lift will be equals to T sine 25 plus the weight. Yeah, so we will simply add them because the total downward force must be equals to total upward force. As he's at a constant position, so that's why And the tension is already given to us. The tension was 280 Newton. So the component of a tension and the weight which are acting downward balances with an upward lift. So he remain at the constant height above the sea. Then force R due to air resistance acting, because he's accelerating, we shows that he's accelerating 1.4. He's accelerating, his acceleration is 1.4. So which position he is accelerating? Horizontally he is accelerating. And they mentioned we need the air resistance. So air resistance try to oppose the motion. So what will the direction of the air resistance to oppose? So say R is the air resistance. And he is accelerating in this way. So it means when we write the formula, like it will be T cosine 25 minus the air resistance R will be equals to MA. Because the horizontal T cosine 25 is acting horizontally minus the air resistance, that is equals to the resultant force MA. If I need the R, we'll move, so T cosine 25 minus M. R is not the resultant force, R is the air resistance they mentioned. In the question, they mentioned that the air resistance acting on the glider is R. He's accelerating. The horizontal component of the tension on the glider, that is the cosine 1. That was 280 cosine 25. So what is the resultant force? The difference of these two will be the resultant force. We have the formula F is equals to MA, where F is the resultant force. So what is the resultant force? It will be 280 cosine 25 minus the resistive force or air resistance will be equals to MA. So it will be 280 cosine 25 minus MA is equals to R, where R is not the resultant force, R is the air resistance which is acting on this glider. Is it clear, this one? Page 29, any doubt? Page 29, 29 or 30? These are the last two pages of the weekly homework. Any doubt in this? Part 2, 3, 4, okay. Consider the forces acting along the slope. Use the data in figure 3.2. Determine the component of the weight. So in the question, a car of a mass 850 kilogram moving at a constant speed. The car, if it is moving at a constant speed, it means that there's no resultant force in this component. The resistive force due to the friction opposed, it varies as the speed vary. And as you can see in the figure, the resistive force for different speeds, different value for the speed. At 9, it is 0.4, the resistive force. So this will have the two components. The weight is acting downward. The weight will have the two components. This will be W sine, W cosine. So the component of the weight which is with an angle, that is the cosine 1, and the component of the weight which is opposite to the angle, that is written with sine. So the weight is acting downward. And if we take the axis here, this will be W cosine theta, and this will be equals to W sine theta. So the W sine theta is acting downward, and that is balances with a, because it is moving at a constant speed, so it means it is the resist balances with a resistive force. So the W sine theta and the force which is opposing the motion when time, the velocity is equals to 9. When the velocity is 9, this is 0.4. The air resistance, or due to the friction and air resistance which is opposing the motion of the car. And they mention the engine exert a force of 2 kilonewton. So there is a force of the engine as well, like force by the engine, which is 2 kilonewton and up the slope. So force of the engine is 2 kilonewton or 2000 newton. The resistive force is 0.4 newton. And as the weight is acting downward, so there will be a component of the weight. One is, this will be W sine theta, the component, and this will be W cosine theta. So means the W sine theta, okay, kilonewton is there. So if it is kilonewton, I have to convert into newton. So it will be 0.4 into 10 to the power 3 newton. So means because it is moving at a constant speed, so no resultant force. So 0.4 exponent 3 plus W sine theta is equals to 2000. If I need the component of the weight, so it will be W sine theta is equals to 2000 minus 0.4 into 10 to the power 3. So when we subtract them, we'll get, it will be 1.6 into 10 to the power. They want us to calculate the component of the weight. The component of the weight, because the weight is acting, so weight is having a component. So we just need the component of the weight, or we need W sine theta. So it will be equals to 1.6 exponent 3 Newton. That is what we have to calculate in the question. Then calculate the power output of the car. Show that the power output is, so if we want a power output, the force required to maintain, how we know we need a cosine or sine, because the motion of a car is given. So with reference to the motion of this car, the W sine theta is affecting this inclined surface. W cosine theta is just balancing with a normal contact force, R. That's why we need the sine component, not the cosine component, because that is along the inclined surface. And if we need the power, power is a product of force and velocity, and the force which is needed to maintain a constant speed, which we need the 2000 Newton, we need to maintain a constant speed, and the constant speed is 9. So we just multiply them, we'll get the power of the engine. And the last part, now the car travel along a road, horizontal road, the output power is maintained. The variation of a resistive force is given. Calculate the acceleration. We less than a minute left. I'll share another link and I'll do this question.